welcome here on stage. Next, Francois, Xavier, Rousselot from the IE Business School International. And you are an expert in the field of machine learning. So now we're moving on to the next topic. So we discussed a little bit what's the idea behind the platform model, and then I said, well, next thing we have to discuss is also about all this buzz about artificial intelligence, and therefore I'm very happy to have you with us. Did you unmute your microphone? Yes, already.
Yeah.
Yes, great. So a warm welcome. So what's your short pitch on why we need to talk about machine learning? Well, I did my pitch this morning,
yeah,
but
it was great.
But maybe what would be your pitch?
Actually, I'm going to use your speech. You know, you said, you know, we need to think about the future, and this session is about the future, and we talk about the future. But we had a great question, and I think the future is now with artificial intelligence and machine learning. Future is now. Now is the time to act, and we need to start. We need to do something at the end of the day. So that's going to be the goal.
But in the Enterprise 2.0 discussions, we have been talking a lot about, well, connecting people and bringing people digitally together, and then they will exchange already, and we have already a better intelligence. So why do we need machine intelligence behind this?
We don't need it, but I mean, for say we don't need it, but the thing is that it's going to disrupt everything. It's going to change the way you work. For some reason, I'm going to explain during the talk. So the question is that now that we have that in our hands, you know, it's going to change everything. How do we do? And I think that disruption, it's about change management. You know, you don't disrupt an industry like that. I work a lot in media, and there's especially the TV, and you don't disrupt the TV industry like that. So the change is going to be gradual. Actually, we have a talk at the end of the day by Xavier, and he's going to also explain that it's a gradual change, and we need to see the big picture, but to start small, and that's, again, going to be my talk.
Great. Francois, Xavier, Rousselot.
So, my name is Francois Xavier. I'm the one between you and your next coffee break. Actually, it's not true. Yes, it's not true. No, I'm saying that. I'm the one between you and the next one before your coffee break, so please stay with me. So again, thanks for the invitation, thanks for the talk, and thanks for the introduction. I suspect that some of you are French here, yeah? So what I'll do, it's okay, you're not the only one. So what I do is that I will repeat the key takeaway. It's going to be like 5 sentences during the speech in French, because I really think that the best way to speak to someone is to speak his native language. As you may have noticed by now, I'm not English, so we're going to have some little moment where I'm going to speak French. Okay, 20 minutes. I'm not a magician. You're not going to know everything about machine learning. My goal is just to create some spark, to initiate the change. So to create the sparks, I'm gonna use 2 questions. The first one is, what does it matter? I mean, you know, why is it so important? You know, there's a lot of buzz around, but you know, why? Why? And the second one, once I will have established that, it's the classical question I get. It's, how do I get this data scientist? You know, this guy that everyone is buzzing about, this magician, this unicorn, superheroes, and so on and so on. So I'm going to say what I'm going to say before saying it. You know, I'm going to say it. Spoilers then. First question, the answer is going to be it's history. It has already begun, and it's going to impact and change everything. I mean, it's countless. Second one, wrong question. We are too old to believe in unicorns and magician. I mean, I know that Potter's was doing good, but we have to stop about thinking about a magician, okay? Actually, I'm going to build on the second one. Today, I think that you all know that, the issue is not how much data. It's not how much data that you have. The issue is about what you do with it. And at the end of the day, the issue is not to find a data scientist. The issue is to know what to do with a data scientist and what to do with the data. I'm going to do the French part. Aujourd'hui, le challenge, c'est pas de recruter un data scientist. Le vrai challenge, c'est de savoir quoi en faire et de tout casser. désolé. C'est de savoir quoi en faire avec le data scientist et quoi faire avec la donnée. Le problème, c'est les idées. So at the end of the day, the issue is to find ID. At the end of the day, the issue is you. Okay? So the goal of this talk is to put you in charge. So when I say we, we, it's all the people who understand that the change is now. And that knows that having big data is not enough. You know, it's not because I bought a data lake that I will solve a problem in my company. But because at the end of the day, it's just work. So the next logical question that you should have in your mind right now is about who is this guy? You know, why is he saying that, and how can he speak about that? So I created 2 frameworks to identify, create, implement successful data strategy, okay, dedicated to ML, of course, to answer the question what to do with the data, how to do it, and to do it well. Donc, que faire avec la donnée, comment le faire et bien le faire. I did it because I teach in IE. So the MBA, it's a great MBA. Look it up on the internet, but it's one of the best MBA in the world. It's not me, it's Financial Times. I also teach at Paris in French, the Exec MBA. Also, great MBA, very focused on digital. So if you don't want to go to Spain, because IE is in Spain, you can stick to Paris and go there. How did I do that? Experience, interview. As we said earlier, the important thing is to speak to people. I mean, you speak to people who did the job, or speak to people who failed to do it. And also, I walk my talk. So I coach incubator, you know, the Paris Tech, HECX incubator, entreprendre. But I also do mission in company. Okay? And again, the goal is what to do with your data, how to do it, and do it. You know, let's do it. Okay, so I'm sure that you are dying to hear more about me, but it's not what you are here for. You are here for machine learning. So, who used some machine learning technology like yesterday, for example, in the room? Don't be shy. Yes? Yes, 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 yes. Okay, who used Facebook or Google yesterday? All right, you all used heavily based machine learning technology lately. I mean, what is machine learning? The official definition is a field of study that gives a computer the ability to learn without being explicitly programmed. Okay, so that's nice. Concretely, it's a set of techniques that turn data into information, into modelization, prediction, and prescription. I like question. So basically, answer the question, what it is, what's going on? Is it normal, not normal? Is it a fraud, not a fraud, etc.? What's going to happen, and what shall I do? Is it clear? You want an example? Actually, I've got an example prepared, so it's fine. I'm going to take the most important thing on the internet. Ta-da! The cat. So it's a bit disrupting, so I'm going to stop this guy because I'm used to teach at 9 a.m. in the morning. So I know that cat video with thing moving on the screen is a good thing to have. Okay, cats. First thing, these are just pixels, but knowing that there is a cat, it's turning this pixel, those data into information. Being able to take this image, put a label cat, and just say that that's a cat, that's data into information. Okay, so that's the first thing. The second thing, so imagine the same thing, being able to say that this cat is playing, this cat is sleeping, this cat is active or snoring or whatever he's doing. That's turning data, or actually information, into modelization. You build a model. You know, what is a cat? Application, it's great because you have a dashboard saying your cat today was very sleepy, your cat today was active above normal, below normal, etc., etc. Then the next step, you know, is this cat about to ruin your favorite sofa? You know, prediction, what is going to do? And then the next action, maybe your webcam should bark to prevent him from doing so, etc. So you can replace the cat by a company and it will be the same, you know, trying to understand, getting the signal out of the noise in your company, then try to understand what's going on, you know, what's going on, and then predict and then prescribe. Is it clear? Okay. Voilà. So let's get rid of some myth. I'm doing that because I have to do it, otherwise we're going the wrong way. The myth is that, I mean, I've got countless snapshots of that. The myth is to believe that ML is for superhero. So ML, it's only about predicting future. You absolutely need to have big data. You need 1 PhD, if not 2, because, to be safe. They build algorithms that, by the way, they don't fully understand. And of course, you're going to do a POC that will, at the end of the day, when one friend of mine tried, at the end of the day, it's going to be very expensive and not that conclusive. It could be true, but I don't think it is. I don't think we should summarize. I think that every time someone is using the mythology like unicorns, magician, and so on about the machine learning business, is doing a bad thing for the business, because it's not bad. There is a fallacy, actually. And the worst thing is that people at the end of the day think it's a buzzword. You think that machine learning is a buzzword. Oh, I did forget to start the timer, so I don't know where I am. So the fallacy that people think that machine learning is all about R&D. It's wrong. It's all about engineering. Today, machine learning, it's all about engineering. Honestly, le ML aujourd'hui, c'est plus de la R&D, c'est de l'ingénierie. There is so much tools available. I mean, comparing to 6 or 7 years ago, there is so much tool around. You can go for a black box. You can still do it by your little hands if you want. You've got library, you've got studio. Every single major company created a ML product. I mean, Google, Amazon, IBM, Microsoft, etc. And I'm not even counting the analytical and predictive analytical. So you have enough tools. So today the question is, it's the classical engineering thing. What is the problem? What is the good question? What are the resources that I have? Do I need to get some and so on? How do I go from that in the context of my company? And just do it. And then try to improve it and implement it. But it's not an R&D problem. You don't need a superhero to do that, okay? You've got a lot of tools. And finding a data scientist is not that difficult. It's just that your expectations are too high. I don't know, I didn't put the slide today because it would have been too long, but if you Google on the internet data scientist unicorn, you will see a lot of examples where you have the expectation. The guy is supposed to know everything about everything. So he's supposed to be a superhero. Just a little thing. It's exactly like in 1998 when we were speaking about the webmaster. The guy was supposed to do everything. He was supposed to buy the server, set it up, design the website, answer the question, the email of the client, I mean, do the business case. He was supposed to do everything. So it's always the same story, new technology. You expect the guy who understands a little bit of it do all the way toward you. No. What I'm saying today is that you have to move toward them. You have to walk toward the machine learning and try to understand what you can do with it, because it's going to be you, the spark. It's going to be you, the guy who's going to do something with it. Clear? Honestly, I spend my mission, most of the subject of my mission is not about technology, it's about finding the right product that fits the company. So why should you take this trend? As I said, it's about history. So I'm going to speed up because actually the introduction covered it a little bit. It's a revolution. Okay, let's speak about, I'm sure some of you know the difference between the first one and the second revolution. It was about controlling the energy to transform something into something in more value. So move something to a better place using a train was transforming something into something of more value. Or of course, doing textile was transforming something into something of more value. When I said transforming data into information, you're transforming something into something of more value. That's why I'm doing a parallel. The first one was, at the end of the day, the impact was not that big. It was the second one that had the biggest impact. The first one prepared it. And I think we can do a parallel. This is the first revolution. This is the first revolution. Actually, this guy said, my goal is to have a PC in every home and on every desk. He left the company when it was true. And those who work in the digital industries know that today the desktop is declining. Okay? So we did this first wave. Now we are on a stage where everything changed. We went from that. I mean, this guy, I respect this guy. So let's say from him, he's a great guy, to that. To this. Everything changed again. The input, the output, the way we store data. I mean, before it was transactional. Now, because we are doing the orders, Now it's about, column-based. Anyway, everything changed. The way we do project, the way we see it actually, because before it was a support function. Now it's a product. Data is a product. Everything changed. But actually, one thing didn't change. One little thing. Who knows Sheldon, Big Bang Theory? No? Yes, some of you know. Okay, so this is funny because it's a guy who trying to do an algorithm by hand to modelize something that shouldn't be modelized by an algorithm. Okay, he's trying to modelize. It's a funny series. Okay, MBA are a bit younger than you. No offense, but so they're a bit more into series. So, why do I say that? Why do we speak about algorithm? Because today, when you do a software, when you do everything, you still do an algorithm. You still think about even. The guy, actually, when he developed, it's still an algorithm. He's writing an algorithm. And this thing didn't change since, it's always the same story. We still think about an algorithm. So why is it important? Let me give you another way that we usually present machine learning. It's the chess game. We say, OK, we feed the machine learning system thousands and thousands of chess game. And at the end of the day, you will have conceptualized what is chess game. You will know how to play, and most likely it's going to beat you. And actually, you could see what happened with the Go game lately. He's going to be the world champion. But what did I say there? So just wait. I just said that I programmed a chess game without writing any algorithm. There is no guy who say, okay, what are the rules? I'm gonna program the rule. I just said that I was able to program something. I was able to get rid of the algorithm. We don't need a human-made algorithm anymore. We have a machine who is doing the algorithm for us, and that's the big shift. That's the little thing that we needed to go all the way through the second revolution, and maybe even a third. Am I clear there? Yeah, the applications are countless. So what I'm saying is that we should stop. Now we can stop to be in Sheldon. We can stop trying to do algorithm on things too complicated and let the machine do. Example, the landscape, as I said, it has already begun. If you take every subject, there's a startup working on it. Honestly, give me any sector, I'll give you application or impact. It will impact everything. We are entering in a new age, the machine age. So just to give you a glimpse of the magnitude of this, one easy thing is that you go back to your company, you look at the floor, and you take the floor where there's a lot of people doing roughly the same thing. Something's going to happen there, because they are most likely turning data into information or information into action, and most likely it's going to be highly scalable for machine learning. Let's go down to business, because I don't want to be too long here. I'm short of time. So there's already a big competition in transforming data into information. Vision, again, that's the example. Nowadays, tomorrow, if you have an application, and the issue is that you have a flow of image, and you want to know what's going on there, you're not going to build it. You're going to ask one guy on the market to use his API and transform that into labels. So that means there's going to be a monopoly on the vision, or oligopoly. And today, it's all about Microsoft, Google. I mean, the market is already settling down. Actually, if you go a little bit further, if you want to go better than vision, go to perception, trying to see the little move, trying to put meaning behind little change. And that's, so that's an example of where you try to analyze the little change in the end to take the meaning behind. And then again, imagine that you put a webcam, a camera in a store or an interview room, able to detect that, you can see the application. So this girl, the last news that she defended her thesis, but the interesting news is that now, since last month, because we're in June now, since May, she's working for Facebook in the R&D department. Another example, speech. Now you can speak to someone who is speaking the same language. Google it, Skype, translation, machine learning. You'll see the demonstration. Something that I'm going to go very fast and we can tackle in the Q&A is that, incidentally, this story about translation using deep learning, we transformed concept into vectors. And that's opened the door to something absolutely insane, which is we can do algebra with concept. So maybe I'll take an example down because it's a side note, but the application I don't think anyone can grasp the explication of that. That means that you take this share, I like this share, minus this share, plus this share, I'm going to give this share. This share is a new one, I created it. Part of the low level of design, machine can do it. Instead of having a guy, a designer, you go to your machine, you say, okay, you know what, I like this, not that, plus this. Let me show you what you can do with that. You can do algebra with concept. Okay. This one I know that. So, the implication for you, how we'll start? Most likely the easy expertise. So finance started way ahead, but accounting, it's an easy expertise, and it will be highly disruptive because at the end of the day, you look at an invoice and you try to know where to put it. So there's a lot of stuff that can be replaced. Lawyers, ERP, of course, audit, prospection. One interesting thing, HR, recruiting also going to be disrupted because the first part, it's already done actually. The first part, most likely your resume are being analyzed by a machine learning algorithm today, and most likely you get some email or some contact because the machine learning algorithm decided if you were interesting or not. But some of the expertise, like detecting faulty code, can also be transformed, disrupted using machine learning. This one is an interesting one, quickly. It was maybe 2 months ago, Google released something that you show him a picture and he's going to tell you where it is. Because he learned from a huge base of pictures taken by people, not the Street View actually, he did the test on another database, the old system that they had. And now you show him a picture and he's able to tell you where it is. So again, you're showing data and turning it into information. Of course, at the end of the day, it's going to be robots. And that, for me, the first mainstream robot that we're going to have is going to be the autonomous car. Because is a set of rules defined. I mean, you have a rule of action. It's a license. You need to have a driving license, so there's some rule. But it's in an internal context. It's outside. It's in real life. And now he's doing it. Okay. So, what's next? It was like a few days ago. So at the end of the day, yes, it's true. And let me tell you how I see things. So machine learning will change the way we work. Because today, we are the humans, the one who turn data into information, decision, prescription, and so on and so on. So we are the one. And what is doing machine learning is basically exactly the thing that used to be our specialty. So yes, they will take part of the job. But it will be more likely to change the way we work. So every company I ended up, very quickly we ended up speaking about strategy. Why am I saying that? Because at the end of the day, it's going to be about strategy and change management, and that's where you kick in. Usually there's three steps when I do that. You've got the big disruption about platform. Most likely, your market is going to be commoditized or uberized. Everything's going to change. It's not tomorrow, but you know that there's a high risk, or you can see it down the road. And ML is going to be a part of that. Okay, so you need also to use ML to find a way to create another value, to add more value on top of that. Okay. The second step, closer, is the current disruption. So you detect it by sometimes because clients ask you to do some stuff that are against the way you do business, or sometimes because you see some little startup around you changing a business model. So it's a current disruption. Again, you need to use machine learning very often they use machine learning to disrupt, as I said, and you want to do it. But it's going to change the way you do business, and it's not easy to change. I mean, we all know that. When I sell machine learning and when I do machine learning project, when I go in a room and I say, good news, you used to be the head of 200 people. Tomorrow you're going to be the head of 50 people. The guy wants to kill me. I mean, I lose a friend instantly. He's on his resume. It's written how many of his head count. I mean, there's a huge resistance for change, of course. So the third one, it's the small one, the first project. And very often, what I do is that I look for a quick win. Again, another way to do that is to have a good quick win. In a big company, very often the project that wins, the project that will start, won't be the project that brings the more value. It will be the project that destroys the less value, but change less things. Because if you come with a great project that creates a lot of value, but change things around, you're not going to start a data business unit. You're going to die. I mean, someone's going to stall the project, it's going to stop. People don't want to change. So that's the first project. And this project is key because you don't start doing machine learning like that. It's a learning process. It's work, as I said. It's not magic. You need to do the connection between your business and the things that you can do. So you need to hire people, they need to work on it, they need to get better, they need to get used to their tool. So this one is key. And this next one, it's you. At the end of the day, all machine learning projects that I did, or studies, or even mission that I did, when we did at the end of the day, the added value was human. Even when you look at the big disruption. We used machine learning as a layer, as steps, where a human climbed on it and provided more value. So if you want, my point today is, the main message is that the time is now, because if you don't have this small project, it's going to be too late when the current description is going to arrive and the big one is going to arrive. And if you need to start it, it's not going to be something in one day. You need to take a small first step now, and for that, I count on you. Thank you. Was that too long? I lost the...
No, it's fine. Any questions? So, it's the same game. I start questioning, and if you have any questions, just raise your hand. So, thank you, first of all, for this nice talk. And, well, we heard a lot about what machine can add intelligence to our organization. So we have this crowd here coming from the background of social collaboration. So what is your thoughts about how this fields will join? So what is machine learning adding to the digital and social workplace, collaboration workplace?
Yeah, that's interesting. There's a lot of things about Slack lately, and again, you have a flow of information, a flow of data. I'm off. Yes, no, I'm off. You have a flow of data, of information, and you want to know what's going on. So you want to have the middle management is going to have a huge impact on the middle management. So you want to know what's going on. You want to detect. You want to be able to transform this data into knowledge, memorization. So if you can take all those discussions and build an intelligent knowledge base on that, it's also a big key. That's a big subject, for instance, for the customer call centers, because they usually use the client knowledge database. But the thing is that what they do, they are creating a layer of intelligence, a layer of knowledge, a layer of expertise that is nowhere or that is somewhere else. So you want to be able to gather that and to create it automatically.
In the early days of the Enterprise 2.0 discussion, we always talked about filtering as the new challenge for this social collaboration landscape, because there's a lot of information. Yeah. Would you say that machine learning is now taking over the filtering?
Yeah, so I said at the beginning, but the big subject is to see the signal through the noise. And that, at the end of the day, filtering. For instance, you have a website, you do a TV ad. It's not social, I'm sorry, but I'm going to just give you an example about signal and noise. You want to see the impact of a TV campaign on your business. So you want to find a signal through the noise. So machine learning is very good at that. And that's usually the first step. You want to find information, so you want to find signal through noise.
Okay, Any more questions? Thank you again.